Hello and good afternoon to each and every one of you present here. Hello and good afternoon to all of you, each and everyone who is present here and will be watching this video. So today we'll be completing our topic of vector in 3D. So these sessions are basically based on previous year question solving and a little bit of tricks and methods and slide concept that we use to solve the problems. Okay. So today we will be continuing our vector and 3D topic. So in the first session, vector was our major coverage, and today we will be trying to cover 3D. So let us see the outline of the session. As you all know, if you have been attending these sessions, then you will know that these sessions are based on mostly previous year question discussion. So again, good afternoon to all of you. Let us move forward with our first question of the session and try to solve the question. Okay, guys. Okay. So the first question tells us that perpendiculars are drawn from the points on the line to the plane x plus y plus z equals to 3. The feet of the perpendiculars lie on the line is. So we have to find out, see, like, let us consider there is a plane, right? This is a plane x plus y plus z equals to 3. Okay. And then there is a line. There is a line. This line is given by x plus 2 by 2 equals to y plus 1 by minus 1 equals to z by 3. So now from this line, like the points on this line, there are perpendiculars drawn to this particular plane. So these perpendiculars will lie on some particular straight line. These perpendiculars will lie on some straight line. Let us call that some straight line that we are supposed to find, right? So what I am saying is, like, any point on this line, any point on the line, any point on the line x plus 2 upon 2 equals to y plus 1 upon minus 1 equals to z by 3. I am saying, let us say this is lambda. Any point on the line can be written as x plus 2 by 2 equals to lambda, y plus 1 by minus 1 equals to lambda, and z by 3 equals to lambda. So from here you get the coordinate of x as 2 lambda minus 2, y as minus lambda minus 1, and z as 3 lambda. and z as 3 lambda, right? So now, since you can see that this line and the plane is not parallel, that means this plane and this line will intersect at some point. Let us say that point is P, right? This line and this plane, since the line is not parallel to the given plane, so the line will intersect the plane at a point. So now x equals to 2 lambda minus 2, y equals to minus lambda minus 1, and z equals to 3 lambda. These are the points on this given line, right? So this will satisfy the plane for a particular value of lambda, right? Because the line will intersect the plane, so it will satisfy the plane for a value of lambda. So let us substitute this. X plus y plus z is 3. So we will substitute this. We will get 2 lambda minus 2 minus lambda minus 1 plus 3 lambda equals to 3, right? So here you will get 2 lambda minus lambda plus 3 lambda. So you will get 4 lambda equals to 3 plus 3. So lambda value will come out to be 3 by 2, right? So for the value of lambda 3 by 2, this line will satisfy the plane and then we will get the point of intersection. So therefore, the coordinate of x will be 2 into 3 by 2 minus 2, which will be 3 minus 2, 1. Y will be minus of 3 by 2 minus 1, which will come out to be minus 5 by 2. And z will be 3 into 3 by 2, which will be 9 by 2. So the xyz for which this line satisfies the plane is equals to 1 comma minus 5 by 2 comma 9 by 2, right? So we have found out the point for which the line satisfies the given plane. Now we can also see that the given line is x plus 2 by 2 equals to y plus 1 by minus 1 equals to z upon 3. So point minus 2 comma minus 1 comma 0 also lies on the line, right? So x plus 2 is 0, y plus 1 is 0 and z is 0. So this point will also lie on the given line. So this point will also lie on the line. Then foot of perpendicular from minus 2 comma minus 1 comma 0 to x plus y plus z equals to 3 will be x plus 2 upon 1 equals to y plus 1 upon 1 equals to z minus 0 upon 1 equals to minus time of x minus x plus y plus z upon 1 square plus 1 square plus 1 square. Coefficient of x square, y square and z square, right? So this will come out to be 3 by 3, which is 1. So the coordinate of x will be -1, y will be 0. So how I am getting these coordinates? Okay, let me tell you. So x plus 2 by 1 is equals to 1, y plus 1 by 1 is equals to 1, and z by 1 equals to 1. So from this you can get that x is -1, y is 0, and z is 1. So the coordinates are -1, 0, 1. So the foot of the perpendicular from the point on the line is -1, 1. And now we found the point P, right? The point P, we found out the point P was 1, -5 by 2, 9 by 2, right? So the direction ratios, the so guys, here I think this x plus y plus z minus 3 will also come. So here it will become 6 upon 3, it will be 2. So this will be 2, 2 and 2. X will come out to be 0, y will come out to be -1, and z will come out to be 2. So 0, -1, 2 is the point, and this, let's say this is Q. So direction ratios of PQ will be 1 minus 0, -5 by 2 plus 1, 9 by 2 minus 2, which will be 1, -7 by 2, 5 by 2. So we have found out the direction ratios of PQ, right? So from this, if we multiply 2 to all the values, so we can get the direction ratios again, right? -7, 5. So this is the direction ratios of the line PQ, which we are supposed to answer, right? So from, like, now I can say the direction ratios of PQ, direction ratios of PQ is equals to 1, -7 by 2, 5 by 2, right? Equivalent to 2, -7, 5, right? So now the equation of the line, equation of required line passing through Q, that is Q point was 0, -1, 2, and having direction ratio as 2, -7, 5 will be x minus 0 upon 2 equals to y minus -1 upon -7 equals to z minus 2 upon 5. So this will come out to be x by 2 equals to y plus 1 by -7 equals to z minus 2 by 5. So this will be the equation of the line that we are supposed to find out. So let us see if there is any new option. So here you can see that so here I think there has been a Here there has been one error, 0 comma 1 comma 2, and the rest is fine. So this will be 0 comma 1 comma 2. Here it will be y minus 1. So here we can see that option D is the same equation that we found out. So option D is the correct answer to the question. Right, guys? So in this question, what we have done is there is a given line, there is a given plane. We have found out the point of intersection of P, and then we have found out a line passing through P as well as a point Q, which is like foot of the perpendicular from a given point. So we are supposed to find out this line equation. Okay, guys. So I hope you understood the question. Let us move on to the next question. Two lines x equals to 5, x equals to 5, y upon 3 minus alpha equals to z upon minus 2 are collinear. And L2 x equals to alpha y minus 1 y upon minus 1 equals to z upon 2 minus alpha are coplanar. Then alpha can take values, right? Since L1 which is equivalent to L1 is given by x equals to 5 comma y upon 3 minus alpha equals to z upon minus 2, right? And L2 given by x is alpha y upon minus 1 equals to z upon 2 minus alpha. So these two lines are coplanar, right? So, so, so we all know that the determinant 5, since x is equals to 5 and this is x equals to alpha, so this will come out to be 5 minus alpha 0, 0, right? So the direction ratios in, sorry, the point in the axis, the vector in the axis and the vector in the y's, which will be 0, 3 minus alpha, Hello guys, welcome back. Due to some technical issue, internet were gone. So here now 5 minus alpha 0 comma 0 3 minus alpha 0 comma 3 minus alpha comma minus 2, right? Here it will be left with minus 2. For y we are writing here y, and for the third line it will be 0 minus 1 2 minus alpha, right? So this value should be equals to 0, right? So from this you can make out that 5 minus alpha into 3 minus alpha into 2 minus alpha minus 2 should be equals to 0, right? So I am keeping 5 minus alpha as it is. Alpha, I am trying to reduce this variable. So this will come out to be 6 minus 3 alpha minus 2 alpha plus alpha square minus 2 equals to 0. So this will become 5 minus alpha alpha square minus 5 alpha plus 4 equals to 0. So here it will become 5 minus alpha into, this will be alpha minus 1 into alpha minus 4 equals to 0. So the values of alpha can be equal to 1, alpha can be equal to 4, and alpha can be equal to 5 that we got from this equation, right? So the answers to this question is option A and option C, right? So I hope you guys understood this question. In this question, you just had to know that this determinant value, since if three lines are coplanar, then the determinant of their direction ratios comes out to be 0, right? So here it is like the first line, it is like x minus 5 upon 0, second line, and the third line it is x minus alpha upon 0. So like this. So in this manner we have written this determinant. Now this is a question based on integer type. This is a question based on integer type of questions. So this question is saying let alpha, beta, gamma be real numbers such that the system of linear equation given to us as x plus 2y plus 3z equals to alpha, 4x plus 4x plus 4 5y plus 6z equals to beta, and 7x plus 8y plus 9z equals to gamma minus 1 is consistent, right? So this equation, this system of linear equations is consistent. Let determinant m represent the determinant of the matrix M given by this value. Now, let P be the plane containing all those alpha, beta, gamma for which the above system of linear equation is consistent, and D be the square of the distance of the point 0, 0 comma 1 comma 0 from the plane P, then the value of mod M is how much, right? So now we are supposed to find out the determinant of matrix M, and to find out, since the determinant of matrix M will be in the form of alpha, beta and gamma, as you can see. So to find out the relation between alpha, beta, gamma, we have been given two information. So the first information that we have been given is that these linear system of equations is consistent, and then P is the plane containing all alpha, beta, gamma for which this linear equation is consistent, and D is the square of the distance from the point 0 comma 1 comma 0 to the plane P. So now we have to find out the value of determinant of M, right? So what we can do here to solve this question, what we can do here is that now, since those three equations are consistent, can I write 7x plus 9y, 7x plus 8y plus 9z minus gamma minus 1 equals to a times 4x plus 5y plus 6z minus beta plus b times x plus 2y plus 3z minus alpha, right? So on comparing the coefficients, you get 4a plus b equals to coefficient of x, that is 7. Then you get 5a plus 2b equals to 8, right? And then since we need to find out a and b, we need only two equations. This is the reason, because it is consistent system of equation, right? So we can write as a times L1 plus b times L1 plus c times L2 is equals to 0, right? So from here, can I say that minus gamma minus 1 will be equals to minus a times beta minus alpha times b, right? I have compared the constants. Okay, so here these are the constants compared. Now on solving the equations, you get a value as 2. Let us solve 4a plus b equals to 7 and 5a plus 2b equals to 8. So multiply this by 2 and subtract this. So you will get 8a minus 5a 3a equals to 14 minus 8 6. So a value will be 2. And if you substitute this a value in this equation, b value will be minus 1, right? So b value will come out to be minus 1. So here I can write down as minus gamma plus 1 equals to minus 2 beta plus alpha, right? So I can write as alpha minus 2 beta plus gamma equals to 1. So this is our equation that we have got. Now the alpha minus 2 beta plus gamma is equals to 1. We found out, right? Now the M matrix is given by alpha 2 gamma beta 1 0 and minus 1 0 1, right? So determinant of M will be determinant of alpha 2 gamma beta beta 1 0 minus 1 0 1. So this will come out to be alpha plus 2 plus 0 minus gamma plus 0 minus 2 beta. So this will come out to be alpha plus 2 beta. Alpha minus 2 beta plus gamma. So alpha minus 2 beta plus gamma value we have already found out, right guys? So alpha minus 2 beta value is how much? From this equation you can tell, right? So this is equals to 1. So that is why mod of m or determinant of m in this case is equals to 1. So the trick to this question was, first of all, since these system of equation are consistent, we can write, let us say that this is L1. I am saying let us say that this is L1, this is L2, this is L3. Since L1 and L2 and L3, L1, L2 and L3 are consistent. That means you can write L1 as lambda L2 plus mu L3 or L2 as lambda L1 plus mu L3 or L3 as lambda L1 plus mu L2. So whichever, like all these things are possible when system is consistent, right? So this is like the important takeaway from this question. So I hope you guys understood this question. Let us try to solve another question and get to the answer. Now, in this question, what we have been asked is that let u bar, v bar and w bar be vectors in three-dimensional space where u bar and v bar are unit vectors which are not perpendicular to each other. So, first of all, from the first line, so this is a question based on vectors, guys. So, in between one or two questions are based on vectors. So, u bar dot v bar will not be equal to 0 since u bar and v bar are not perpendicular, right? So, and the other relations that have been given to us is that u bar dot w bar is 1, v bar dot w bar is 1, and w bar dot w bar is 4. So, w bar dot w bar is mod w square, which is equals to 4. So, w bar can be equals to mod of w will be equals to 2, right? So, we know now from this thing that mod of w is equals to 2. Now, if the volume of the parallelopipe whose sides are represented by the vectors u bar, v bar and w bar is root 2, then the value of 3u bar plus 5v bar, mod of 3u bar plus 5v bar. Okay. So to find out mod of 3u bar plus 5v bar, to find out the mod of 3u bar plus 5v bar, we need angle between u bar and v bar. So that will become easier. To find out the angle between this u bar and v bar, volume is given. Volume of parallelopipe is given to us. Okay. So what we will do here is that So now we know that box product of U bar, V bar and W bar is equals to 2, since this is equals to the volume of parallelopiped, right? So now we know that what can be like to represent the box product in a fashionable way. We already knew how to write the box product. U bar, box product of U bar, V bar and W bar can be written as determinant of U bar dot U bar, U bar dot V bar, U bar dot W bar. Then V bar dot U bar, V bar dot V bar, V bar dot W bar, W bar dot U bar, W bar dot V bar, W bar dot W bar. So this is something that you have to remember, and this is important. So we have studied during our sessions that the box product can also be represented in that form of determinant, like in the form of determinant like this. So U bar dot U bar, U bar dot U bar, since these are so U bar and V bar are unit vectors, right? So U bar and V bar are unit vectors. So since this is a unit vector, their dot product will be 1 because these vectors are same, and U bar dot V bar will be as it is, which is not known to us, and U bar dot W bar, U bar dot W bar will again be 1 because U bar dot W bar is given to us, right? Here, here you can see that U bar dot W bar is given to us as 1, right? So then again V bar dot U bar, this will be 1, this will be 1, V bar dot V bar is 1. V bar dot W bar is again given to us as 1. This is V bar dot W bar, this is U bar dot W bar. And W bar dot U bar is 1, W bar dot V bar is 1, and W bar dot W bar is 4, which is given to us, right? So let us say that U bar dot V bar is A, this is A. So what we will get here is 4 plus A minus 1 minus 4 plus 4A square plus 1, right? So this is the determinant value, right? So now what we have gotten here is 4 minus 2 is 2, 2 plus 2A, 2 plus 2A minus 4A square. So this is the determinant value, and this is equals to, so this is the square of that determinant. So this is equals to 2, right? Since this box product is equals to 2, the square will be equal to this box product is equals to U bar, V bar and W bar. Box product of this is equals to root 2. So therefore their square will be equals to 2. And from here we can solve out that what will be the values of A, right? So from here you will get that 2 will get cancelled. 4A square minus 2A will come out to be 0. And here you will take 2A common. Here you will take 2A common, you will get 2A minus 1 is 0. So A comes out to be 0 and A comes out to be half. right? So now A, what was A? What was A for us? We had taken u bar dot v bar to be A. So we have gotten u bar dot v bar value to be 0 or half. But in the question itself, it is given that they are not perpendicular. Therefore, u bar dot v bar cannot be equal to 0, right? So what we will do here, we will reject this value and we will accept this value. And u bar and v bar are unit vectors, right? These are unit vectors. So this will be mod of u bar, mod of v bar into cos of theta, theta being the angle between u bar and v bar. This comes out to be half. This is 1, this is 1. Right? So cos theta value comes out to be half. So theta value will be equals to 60 degree. So now mod of 3u bar plus 5v bar will be equals to under root of 3 times under root of mod 3u bar square plus 5v bar square plus 2 times mod 3u bar mod 5v bar into mod into cos of theta, right? So this will be under root of 9 into u square is 1 plus 25 plus 25 into v square. Mod of v square is 1 plus 2 times 3 into 5 into half, right? So this will get cancelled. What we will get from this is under root of 9 plus 25 plus 15. So we get under root of 49. So this is 7, right? So therefore, the answer to our question, mod of 3u bar plus 5u bar, we have found out to be 7, right guys? So the value to this question, the value of answer to this question is 7. Okay. Now let us move on to another question and try to find out the solution. Now, three lines are given by r is equals to lambda I, r equals to mu I plus j, r is equals to v times I plus j plus k, right? There are three variables, lambda, mu and v. Let the lines cut the plane x plus y plus z equals to b at points a, b, c respectively. If the area of the triangle ABC is delta, then the value of 6 delta square, right? We have to find out the value of 6 delta square, right? So, since r is equals to lambda I, so the point A can be put as lambda comma 0 comma 0, right? And B can be put as mu comma 0. C can be the point which will be v comma v, right? So these 3 points are cutting the plane at one, like x plus y plus z. These are cutting the plane x plus y plus z equals to 1. So these points are cutting the plane x plus y plus z equals to 1. That means these points will satisfy this plane. That means these points will satisfy this plane, right? So if these points are satisfying this plane, so point A was lambda comma 0 comma 0. Point B was mu comma 0, and point C was v comma v, right? In the plane x plus y plus z equals to 1, right? So point A, if you want to find out point A, which will be substituted in this, and this will be substituted here, this will be substituted here. So you will get lambda plus 0 is 1, mu plus 0 is 1, v plus v is 1. So you get lambda value as 1, mu value as half, and you get v value as 1 by 3 from these three equations. So these points can be written as A will be equals to 1 comma 0 comma 0, B will be equals to half comma 0, and C will be equals to 1 by 3 comma 1 by 3 comma 1 by 3, right? So these will be the 3 points. Now we have found out 3 points which are the vertex of the triangle. So the area of triangle, ABC equals to, will be equals to half times AB cross AC, right? So this is the formula for area of triangle, right? Similarly, there is the area of parallelogram formula in terms of diagonal as well in terms of adjacent sides. Okay, guys. So please remember this formula. This is important formula. Okay. Now, so for to find out area of triangle ABC, what we are going to do is half times modulus of AB bar cross AC bar. So to find AB bar is, you know the coordinate of B and you know the coordinate of A. So it will be half minus 1 times I cap plus half, half minus 0 times J cap plus 0 minus 0 times K cap. So this will be minus half I cap plus half J cap, right? Similarly, AC bar will be equals to 1 by 3 minus 1 I cap plus 1 by 3 minus 0 J cap plus 1 by 3 minus 0 K cap. So this will come out to be, minus 2 by 3 I cap plus 1 by 3 J cap plus 1 by 3 K cap, right? So we have found out these two vectors. Now to find out AB bar cross AC bar, what I'll do is I'll find out the determinant of I cap, J cap, K cap minus half 0 minus 2 by 3, 1 by 3 comma 1 by 3, right? So this will come out to be I cap के साथ it will be 1 by 2 into 1 by 3 into I cap, which will be 1 by 6 I cap, J cap 0 0, so 0 plus K cap minus 1 by 2 minus 1 by 2 and 1 by 3, so it will be minus 1 by 6 K cap, right? Minus of, here it will be minus 2 by 3 into 1 by 2 into K cap, so 2 will get cancelled, it will be minus 1 by 3 K cap. Then here it will be 0 I cap and here it will be minus 1 by 6 J cap, right? So you will get 1 by 6 I cap and 0 I cap. So 1 by 6 I cap, 0 J cap, and here minus minus plus 1 by 6 J cap. Minus 1 by 6 J cap, minus 1 by 6 K cap, minus 1 by 6 K cap, and here you will get plus 1 by 3 K cap. So you will get 2 times, and here it will be 6, so it will be 1 by 6 itself. So plus 1 by 6 K cap. So you got the value of A bar cross C bar. So mod of AB bar, so you got the value of AB bar cross AC bar. So mod of AB bar cross AC bar will be 1 by 6 times root 3, right? So this you will multiply 3, root 3. So this will become 3 upon 6 root 3. So it will be 1 by 2 root 3. So this you have found out. Now half times mod of AB bar cross AC bar will be equals to 1 by 2 into 1 by 2 root 3, which will be 1 by 4 root 3. So 6. So this is equals to the delta value. Now we are supposed to find out 6 delta whole square, right? So this will be equals to 36 into delta square. So this will come out to be 36 into 1 by 4 square into 3, right? So 3 ones are 3, 12s are, and this will be 12 by 16, so 3 by 4. Now 6 delta square value has come out to be 3 by 4, which will be equals to 0.75. Okay guys, so the answer to this question is 0.75 or 3 by 4. Okay, I hope you understood this question. Let us try to solve another question. In this question, it is saying that let P be a point in the first octant whose image Q in the plane x plus y equals to 3, that is the line segment PQ, is perpendicular to the plane x plus y equals to 3, and the midpoint of PQ lies on the plane x plus y equals to 3. Lies lies on z axis. Let the distance of P from the x axis be 5. If R is the image of P in the xy plane, then the length of PR. So here I am saying P is the point in the first octant. I am saying let P be alpha, comma, beta, comma, gamma, right? And R is the image of P in xy plane, right? So if it is the image of P in xy plane, then we know that R can be written as alpha comma beta comma minus gamma, right? Since it is the image in xy plane, the z coordinate will change and it will become negative to what it originally was, right? So this is one of the tricks that one should know. And then also Q is image of point P in the plane x plus y equals to 3. So x minus alpha upon 1 equals to y minus beta upon 1 equals to z minus gamma upon 0 will be equals to minus, since it is image, we know the formula, minus 2 times alpha plus beta plus 0 minus 3 upon 1 square plus 1 square, right? So this will get cancelled. This will become minus 1. So minus 1 into alpha plus beta minus 3, right? So x minus alpha will be equals to minus alpha minus beta plus 3. So x will be 3 minus beta. Similarly, y will be 3 minus alpha and z will be gamma, right? So we have just equated x minus alpha with the rightmost term, y minus beta with this term, and z minus gamma upon 0 with this particular term, right? And since these points, since q lies on the z axis, since q lies on the since Q lies on the Z axis, that means since Q lies on the Z axis, since this lies on Z axis, so any point on the Z axis is represented by 0, 0, lambda, right? Gamma. 0, 0, gamma, right? So this will imply that 3 minus alpha, 3 minus beta and gamma are equivalent to 0, 0, gamma. So alpha value will be 3 and beta value will be 3. So the point P will become 3, 3, gamma, 3, 3, gamma, right? So given the distance of P from the x-axis, the distance of P, distance from x-axis is 5. So 5 will be equals to under root of 3 square plus gamma square, right? So 25 minus 9 will be equals to gamma square. Gamma value will be plus minus 4. Then PR will be equals to 2 times of gamma, right? Mod of 2 times of gamma, because R is the image of P in the xy plane. So PR will be 2 times of gamma. So this will come out to be mod of 2 times 4 or minus 4, which will obviously be equals to 8. Right, guys? So the value of this, the answer to this question is 8. I hope you guys understood this question. Let us try to solve one another question. Now, let P be the image of the point 3, 1, 7 with respect to the plane x minus y plus z equals to 3. Then the equation of the plane passing through P and containing the straight line, right? So what it is saying is that P is a point here, P is a point 3, 1, 7, and there is a plane, right? So the image of P with respect to this plane is a point Q. So sorry, P, there is a point 3, 1, 7. There is a plane x minus y plus z equals to 3. The image of this point in this plane is given by the coordinates of P, right? Is mentioned as P. Then the equation of the plane passing through P. So there will be a plane that will pass through P and contain this line. This line given by x by 1 equals to y by 2 equals to z by 1. So we have to find out the equation of this plane is what, right? So this is our question. So we have interpreted the question and we know now any line passing through P, right? Any line passing through P will be x minus 3 upon 1 equals to y minus 1 upon minus 1 equals to z minus 7 upon 1. Now distance of point P from given plane will be minus 2 times 3 minus 1 plus 7 minus 3 upon 3, right? So this will be minus mod of this. So this will come out to be 4, right? Now, x minus 3 upon 1 equals to y minus 1 upon minus 1 equals to z minus 7 upon 1 will be equals to this value minus 4. So the point P will come out to be minus 1 comma 5 comma 3. So we have found out the coordinates of P by using the image of a point formula. Right, guys? So equation of plane passing through P will be a times x plus 1 plus b times y minus 5 plus c times z minus 3 equals to 0, where a, b, c is the direction ratios of the perpendicular to the plane, right? So this plane passes through this line. So ABC, this is a plane, perpendicular direction ratios are ABC, and the line that lies in this plane has the direction ratios 1 comma 2 comma 1, right? From this equation you can say 1 comma 2 comma 1. So the value a into 1 plus 2 into b plus c into 1 should be equals to 0, right? Because these two are perpendicular, so the dot product will be 0. The plane will also pass through origin, since the line is passing through origin. So the plane will also pass through origin since the line is also passing through origin. So we will get this plane. You can see that the line given to us is x by 1 equals to y by 2 equals to z by 1. So this line is passing through origin, right? So the plane will also pass through origin 0 comma 0 comma 0, somewhere will lie on this plane. So it will satisfy here. So we will get a into 0 plus 1 plus b into 0 minus 5 plus c into 0 minus 3 equals to 0. So a minus 5b minus 3c will come out to be 0, right? Now solving these two, I am trying to solve these two. You will get a upon 1 equals to b upon minus 4 equals to c upon 7, right? So the equation of plane will be equal to a times x plus 1 minus b times y minus 5 plus c times z minus 3 equals to 0, right? So if you solve this, I am writing it again. A times x plus 1 plus b times y minus 5 plus c times z minus 3 is 0. So from here you will get x minus 4y plus 7z, here 1 minus plus 20 and minus 21, right? this will be 0 since this is passing through origin, right? So this is our answer to the question. Right, guys? So as you can see, option C fills the answer to the question. So I hope the session was understood by you guys. Please read vectors and 3D and revise the formulas plus a little bit of concepts, and JEE Advanced will be pretty much easier for you guys. Thank you so much. Have a good day. Let us meet for the next class tomorrow.